So can you start the session, guys, now?
Yeah, Daj.
Yes, thanks.
Okay, so today I'm going to discuss the OSPF now.
Mhm.
Okay. So this is your OSPF, guys.
Mhm.
OSPF stands for, guys? Any idea about OSPF?
Open shortest path first.
Okay. Then what else it does?
It automatically selects best path to reach the destination.
It automatically select the
Best path to reach the destination.
fair enough. Anything else apart from that? So OSPF is your open standard, guys. OSPF is an open standard routing protocol. So it works using the your Dijkstra algorithm. Okay, I think remembered. So this was a question I was asking your pre-assessment. I think most of them answered this.
Yes.
Okay, I think this. Okay, actually it use OSPF. SEFP, shortest path first. Yes, sorry. Shortest path first algorithm.
First.
Okay, this is the algorithm which will calculate the best path selection in your network. So whereas your Dijkstra, it is the name of the person. Maybe I don't know, he or she. Okay, that is the name they have given. Actually, the technical name is SFP algorithm. SPF algorithm. So this is the algorithm where we are using it. So what is the main advantage of this one, guys? So OSPF provides the following features: minimize the routing traffic updates, because as you know that, okay, so your OSPF, okay, is going to implement in big networks. Okay, as you know, the limitation of RIP is 15, and your EHRP is how much? 255, right?
Yeah.
So allow scalability, whereas limitation of these guys. So that's the reason they have come up with the OSPF. So OSPF, you talk about OSPF, so it has limited hop count. Suppose we are VLSM CADR, it also support a multi-vendor deployment. Means even the non-Cisco device also we can able to configure. Can able to configure your OSPF. Okay. So
Good
they have a
morning,
few
Taj.
things. Very good morning.
Yes, this side.
For you is good morning. For us is good afternoon.
Good afternoon.
Yes, good afternoon. Me Satya over here.
Satya, now you joined.
Yeah, actually, sorry.
He was sleeping. Yeah.
Okay. It's okay, no issues. Okay. So let's start with there are two types of packets available in your OSPF. That is hello and your LSA. So what is LSA, guys? LSA is something with a
Link state advertisement.
yes, link state advertisement. So what it does, it tries to form the adjacency to the neighbor router, to your neighbor router. So we have to remember this. These are the two types of packets available in your OSPF, hello and LSA. So LSS we have many types. Okay, LSA 1, 2, 3, 4, 5, 6, up to we have 11 LSS. How the hello packets works, guys? How it will form the adjacency? How is going to initiate? Okay, A will send. It will send the multicast to both router B and your router C. When router A starts sending your hello packets, it uses the 224.0.0.5. Okay, what kind of this IP address is this? This is called your multicast IP. This is your multicast IP. Okay, this is for sending. For getting the updates from the another router, okay, it use multicast IP 224.0.0.6. Okay. Hello packet are received by all its neighbors. So B will write A on its neighbor. So B will write A. Okay, A is my neighbor. Same like C also writes A is my neighbor. Okay, this is how they will form the adjacency. Okay, so your small frequency issue the packets, so discover neighborship, negotiate, form the adjacency. So then verify continuous availability for your neighbors. So hello packet sends LSS and built-in maintain your topology table. So here it maintain your topology database, not table. So hello packet also discovered by 224.0.0.5. Just remember guys this one. Okay. Is it getting this one guys blinking and from my side guys screen?
No.
No, right?
No.
Mm-hmm.
Okay. Okay, so now guys, LSA, what is LSA guys? LSA data packets contain the link state and routing information that are shared among the OSPF. So it is advertisement. It will send the data packets contain the link state. It send your routing information that share among your OSPF routers. Just it will share it. The LSA are shared only among the router which is to whom it has been formed the adjacency. So it will send the adjacency only who it has been formed the neighborship, not for all. Once they form the neighborship, then only it will send your all routing updates. So LSA packets are used to update and maintain your topology table. Same thing. So it maintain your topology database, like how many routers has been connected for each router. That all it will maintain in your topology database. So link set types. So as I said, same thing guys. You can see neighbor topology routing. So same thing like your EHRP, right?
Yes.
Right. So your OSPF also maintain these three tables. So neighbor, topology, and routing table. So let's discuss this. What is neighbor table? So contain information about neighbors. Okay. It contains the information number to whom it has been connected. Okay. Neighbor router which share the links on the same network. Another relationship adjacency. Not necessary all the routers. It will send the updates only for the neighbors, not for all. Okay. Your LSA update are only when adjacency is established. This is very important. So we have to remember that, okay, once this router has been formed the adjacency, okay, it will send the updates to only this router, not for all. Suppose you connected one more router here, okay, which is not formed still adjacency, just you have connected. So now this they have formed already adjacency sending the hello. Okay, only this guy will share the updates and this guy will share the updates, not for this guy, which is not yet formed any neighborship. Once they form the neighborship, then only it will share your routing updates. Otherwise, no.
So here also, like, do we consider this AS number, autonomous system number?
So here also same, but here they have given your process ID. Process ID. Process ID. Which starts from 65,535. The process ID of this one should be same. If you give OSP of 10, here also OSP of 10. Okay, then only they form a neighborship, otherwise no. In the topology, so it contains the information about the networks, paths, okay, we reach to any network. All LSA are entered into the topology table. When topology change, LSA are generated and send the new LSA. Any changes of the topology, suppose if you added one more network here, okay, so this will update to him. Okay, this guy will update to this one. Your new LSA will be generated. Link state advertisement. Same thing as simple as guys, because when you buy any new car, okay, you have the neighbors which already formed. You know their your neighbor very well. If you buy any your Mercedes or BMW RD car, okay, so what we are going to? Who is the first person to know?
Neighbor.
Neighbor, right?
Yes.
Neighbor is the first person. Okay, then it will what happen? LSA will generate your new LSA. It will give update to directly to the neighbor, right?
Yes.
Okay, first it will update to directly to the neighbor. Same thing here. In a topology, okay, contain information about all the network and path of reach to the network. It will maintain like how we can reach, which is the shortest path, how we can route the traffic. Okay, all LSA are entered into your topology table. When topology change, your LSA are generated and send the new LSA. If any change in the topology, they'll create the new LSA and update to your neighbor. On the topology table, an algorithm run to create your shortest path. So this algorithm known as your shortest path first or Dijkstra algorithm. As we can see, this is your Dijkstra algorithm. In your routing table, same thing. Your how your this thing will form your EAGRP. Same thing here also. Also known as a forwarding database. Generate when algorithm is run on the topology database. Okay, a run table on each router is unique. Running a table because each routing table they have a different routing table, not the same guys. Remember that because they will be containing your all different network routing table, right?
Yes.
Not the same.
Yes.
So OSPF terms. So we need to remember these all things. Okay, so we have links, router ID, neighbor, adjacency, OSPF area. So we should discuss this OSPF area now. So we have the backbone area, and you have internal routers, and your ABR, area border router, and autonomous system border. So these are the terms we should remember. So what is a link? Link is one which has got a state up and down, and it has IP address and fast Ethernet network type, bandwidth. Addresses of other router attached to this interface. So as you can see, this is the link guys it's talking about. So what kind of link it is? How many types of link guys?
Hello and
LAN link, WAN link, then. So what kind of link is this? This all.
Maybe a serial link.
no serial is here.
Swati?
It's the serial link, I think, WAN, red color showed, right?
Red color.
Yes.
Right. Yeah, I think so. It should be LAN. I think so. It should be a LAN.
I mean,
The question
type
mark
is
what
that
you
one?
asked was a LAN local area within connected within a small
Yes,
distance.
always remember, whenever router to you connected, maybe your serial or optical fiber cable, anything. Okay, this will be your WAN link.
It's connected with
Okay.
router. It should be a WAN. Okay.
Okay. When it is connected to switch, where a lot of end user devices connected, and this is called your
LAN.
LAN link. Remember, guys, this is quite very important to understand this. Okay, these all are your WAN link.
WAN link.
Everything are WAN here. when I connected, okay, one switch here, connected or some pieces. So then this is called your LAN link, because LAN, right, inside you're running some network. Again, you connect one more switch, connected. These are the LAN, right?
Yes.
Okay. Important to remember, guys. So what is the router ID here? Okay, so your router ID is an IP address used to identify the router, used to identification of your router, guys. So Cisco choose the router by using the highest IP address of all the configured loopbacks. So here the highest IP address will become your router ID. Means he'll become your DR. DR means designated router, guys. DR means designated router. If no loopback are configured with the address, OSPF choose the highest IP address of all the active physical interface. Which has caused the highest IP address, that guy will become your designated router. Same thing, election processing switch. Here a little bit different in OSPF. Because the OSPF will be configured where the network is very huge. We'll be having 10,000 employees in the organization, 20,000, 30,000. In that scenario, OSPF will be configured. The network configuration is very huge, guys. The configuration of your network. So you can manually assign the router ID. This is the option for the network engineer. So you can able to configure, you can give your own router ID, guys. The router ID must be always up. Therefore, the loopbacks are preferred because it's a virtual, right? This is not a physical interface. That is the reason ways your loopback interface are very important. Which will never go down, right? Correct, guys.
Yes.
So which will
Yes.
never go down. Okay. And your neighbor, two or more router of that having the interface on the common network. Example, two router connected on a serial link, several router connected to the common internet frame relay. Communication take place between among the neighbor. Neighbor should be found. This is talking about neighbor how it will found. So it should be connected in the same network, not with the different network, guys.
Okay.
HSSP form, it is if it is two router that are permitted directly exchanging of your routers updates, not all the neighbors. It not form the adjacency other neighbors. Only it will form the relationship between the two routers that are permitted directly exchange the routes, exchanging the updates.
Okay.
There is area concept here because there's a lot of OSPF is configured where we are having hundreds of routers are running in your rack.
Okay.
Yeah. So you can see. So what it's talking about, for to configure, there must be one area 0, guys, always. Okay, all areas must connected to area 0. Remember, area 0 is your backbone area. Okay, the router which is connected to area 0, we'll call it as your ABR, area border. The router which is connected to other routing protocol, like you're running here RIP, you're running your EIGRP, you're running your OSPF other network. So this is called your ASBR, autonomous system border. Just remember this term, guys. So OSPF areas. So here, what is talking about a group of contiguous networks and area. So we'll be having your area ID. Router can be membered or more than one area. Okay. Routers can be member of more than one area. area border router. So doesn't mean that, so this area what is talking about, this can be member for other area also. Maybe your area 3, like this is talking about. Okay, all router in the same, has the same topology. When multiple area exists, they must be always be your area 0. Remember guys, if you have more area, yes, I think, yeah, Y area. Let me explain this. Decreasing of your routing overheads. So as you know that, so in each router we can connect another 200 pieces, each router. Just imagine if we connect 100 routers. So what could be your updates? Your update is very huge, right? They are going to exchange hello information every seconds. So every second is going to send hello message, right? So that's the reasons it will decrease your routing heads compared to multiple small broadcast domain instead of your large one. Because instead of sending for to all, so when we make it area concept, what is here? It will become your small broadcast domain instead of one large one. It's became loop, right? Because there's no area concept. What happened? So each router is going to exchange with each other, guys. They keep on exchanging their updates. So now it has, so once if you have done the area concept P, means the convergence will be speed. Okay, and your confident network instead, example like your route flipping to single area or multi area, means you can able to connect it for your single zero area 0, or one area can be connected to your multiple area. So as per this one, guys, so consideration of the complex of the setting of the OSPF, CCNA certification deal with only single area. Okay, for your CCNA, but I'm going to train for a multi area, guys.
Okay.
Not with single area. I'm going to, today we'll do single area and multi area levels.
Okay.
Okay, this is the terminology, guys. You can see backbone area 0, which is all the areas must be connected to your area 0. How this guy has been connected here.
Yeah.
Okay. So LSS areas. So links in that bed means communicate with the adjacent router in the same area. Subsequently, the change in the link state can flooded to all the areas routers via LSS. It will change the new, any changes, it will send, it will create the new LSA and update to your all neighbor routers. In the last network, okay, multi-area may be created. Okay, so LSA are sent only to adjacent router in the same area. So here is talking about just if any changes in the topology, it's going to create a new LSA, it will update to all the routers. So which is connected to the same area, guys. So how it is select the path? Okay, changing in the topology, as you know that it will try to re-establish the path. So as we can see, it will re-establish the path to know the network. So using shortest path algorithm developed by by one of the computer scientists by name Dijkstra. Okay, guys. So it is the name of the person.
Yeah.
I don't know he or she. Okay. So actually algorithm name is shortest path first. This is algorithm name. So which is going to calculate the best path in the network. So because you know this is the very big network. So which is the best path? How is going to select? Okay, this algorithm it is already inbuilt in your operating system. It is your iOS.
Okay.
So this is done by individually routing using your whole network to lead to rapid and accurate conversations. Keep on sending hello message. Okay. If any changes, is try to calculate the shortest path again. How I can reach to him.
Okay.
Okay. So based on the detailed knowledge, every link in the area OSPF cost will be considered. So here cost also play a major role. So as you know that the lowest cost is the best.
Okay.
right? The cost will be calculated based on these values. So we can see based on these calculations going to calculate. So OSPF cost 10 to the power of 8 divided by your bandwidth. Okay. So whereas your EHRP, how is going to calculate? Who will tell this?
So,
Reliability and
MTU.
MTU.
this is how OSPF is going to calculate the metric, right?
Okay.
Here the metric calculations will be calculated based on 10 to the power of 8 divided by bandwidth. But EHRP by default is going to calculate what? By default is going to calculate these two parameters.
Liability and metric. Yeah, MTO.
Okay, bandwidth and delay by default to calculate the best path. Okay, in OSPF, guys, this is very, very important, guys. So OSPF cost is going to calculate usually so 10 to the power of 8 divided by bandwidth. So bandwidth will be depending upon your so what kind of connectivity you are using. Your communication media. Maybe you are using CAT cable, your optical fiber cable, or serial cable, or you are using a coaxial cable.
Okay.
Depending upon that.
Okay.
Okay, let's talk about neighborship. So here, these are things I want to explain you important in OSPF. So 3 types of neighborship is going to form it. First thing is okay, BMA. What is BMA? Okay, the BMA is nothing but your broadcast multiple access, point to point, and non-broadcast multiple access. So these we have to remember, guys. This part. Okay, when there's a point to point, no need to configure the OSPF area 0. Okay, area concept will be configured where if you have many areas, many networks are running, many routers are running in your organization. So this is the how OSPF network types. So broadcast multiple access, point to point, okay, non-broadcast multiple access. So this we have to remember, guys. So adjacency, how is going to form your adjacency? So first thing is point to point. Okay, so point to point how is going to form for all the router form the adjacency. So BMA, NBMA, one router is elected as your DR. DR means
Destination.
designated router.
Okay.
Please remember, guys, designated router. Okay, and BDR is backup designated router. Okay, so backup designated
Route.
Okay, so DR has to be adjacency with every neighbor router. Okay, DR is one is going to form your adjacency. DR is here is in OSPF is a team lead, guys. I think in your this tip one of the I think team lead, right? Hema and is there any Divya Bharati? I think they are the team leads here. Means they are the team leads. Means they are going to form a neighborship for all the people which is connected to them directly. Okay, they are trying to form the neighborship.
Okay.
When LSA update or exchange only to the DR. If one of the member has learned new technology, okay, they can update to only for their team lead. Your team lead is nothing but your DR, designated router. So DR is a router which has the highest priority. Highest priority will become your team lead. All Cisco router has the priority 1 by default. Okay, for Cisco routers, not for Cisco switches. The priority bit is how much? Is it correct? For switch. If the priority is same, then router ID is seen. The router ID is the highest IP address of all the interface. Okay, of all the interface, who has got the highest IP address? So that guy will become your designated router.
Okay.
So this is the point to point. So how the point to point is going to work? So usually, let me check. So what is talking about? If no DR/BDR election required, so usually serial interface running either P2P or HDLC. If it is connected in this way, okay, so no need of election process, no DR/BDR election.
Okay.
Directly connected, not required, right?
Okay.
OSPF auto detect its interface type. So your OSPF has got capability, especially your shortest path algorithm. So it's going to detect like what kind of interface it is. Maybe because right now, if you see such type of link symbol, this is your serial, guys. Always remember.
Okay.
Serial interface. This is also serial. OSPF packets sent usually by multicasting 224.0.0.5. Okay, to receive 0.0.6. Remember, guys, this. Okay, this is to send, this is to receive. Okay. So you can see, right? So packet sends to DR, use 0.6. Packet from DR to other router, it use 5. So packet to DR, because these guys send any update, okay, can send DR by using .6 IP address, that is 224.0.0.6. Okay, when these guys share the update or these guys share the updates down router, it use which IP? 224.0.0.5. Okay, so this is the interview question, guys, or even in your exam also. You should remember this is the multicast IP.
Okay.
So election or DR/BDR, guys. So how the election will be given? The highest priority will become your DR. That the reason has become a DR. Hello packet are exchanged via your IP multicast. The router with the highest priority is selected as a DR. If the priority are same, router ID you will see. Use the router ID as a your tie breaker, or else manually also we can able to change your router ID, guys. No problem. That also is possible. Same, like whichever router you want to make DR, we can select.
Okay.
Okay, same thing is talking about terminology. The responsibility of the DR is, okay, when a router is seeing the new or changing link, it send the LSA to the DR using the particular multiclass IP address. Same thing, if any changes, okay, so let me show you an example. If the DR then forward LSA to all the routers, so what is going to so what is talking about? The DR forward the LSA to all other routers to whom it has been formed the adjacency. So when it will send your LSU will be sent when new network has been attached. New network. Suppose example, this is my router, okay, which is running your OSPF, which is connected. Okay, and there's a new network which has been connected here. Okay, so this will send your LSU. LSU means link state update to these routers. So okay, fine. Please take this new update by using multicast IP. What is the multicast IP for this? 224
0.0.5.
Yes, very good. It uses this IP address to update. Remember, guys, this.
Okay.
Okay, if you talk about summary, guys, as you know that not this 110, right? AD value.
Yeah.
Correct?
110. Yeah.
Yes. So hop count is unlimited. Unlimited hop count. What about RIP? 15, right?
Yeah.
What about EIGRP?
90. 90.
255.
255. Sorry. Hop counts. Yeah.
Hop count.
Yeah.
So hop count here,
Unlimited.
OSPF, unlimited.
Unlimited. Good.
Unlimited. Okay, this will be used like where the network is very huge. Okay, the metric calculation will be done via cost minus 10 to the power of 8 divided by your bandwidth. How it will calculate the metric. Metric, so based on the metric calculation, so OSPF is going to select the best path in the network.
Okay.
It's a classless, it will support VLSM, load balancing up to 6 routers, required more processor and power because OSPF consumes more hardware resource.
Okay.
Means your router should be very high end
Okay.
router. Because the AD value is 110, right? It's totally depending upon your hardware resource. It consumes the more hardware resource, CPU, RAM, everything it will take more. Because if you see any rack, there's a lot of noise. I think how many people have seen anybody rack, guys? Anywhere?
No.
Okay, so at least in the office you check once. Required more this in processing power, right?
Okay.
Your processing power required more.
Okay.
Okay, how to configure? Same thing your BGP, guys. Same thing your EHRP and RIP, how you're going to configure. So now we are going to configure your OSP.
Okay.
So let me show you. I think already explained here. This is how it's going to form the adjacency, guys. Neighborship.
Okay.
Your OSP. It send the hello message. Suppose this is my router, just connected like this. Okay. So first thing is it'll send the hello message. Okay. So then database description, link state request. Again, it will send the link state request. So I want to form a neighborship with you. So this is my network. So example, you are running 1.0 network /24. Okay. So then once it has been sent, this guy accepted, then it will send your LSU link state update.
Okay.
So then link state acknowledgement, this guy will see. Okay, fine, I received it. Link state acknowledgement. Okay. LSA is different. LSACK is different, guy. Don't get confused.
Okay.
This is advertisement. And this is acknowledgement.
Acknowledgement.
So here we are seeing acknowledgement will be happen when initial conversation. When they're supposed to form the neighborship. Okay. So let's jump to the lab, guys. Okay. Because other side already I opened it. Okay, so let me. So I'm going to use the existing topology, guys, to configure OSPF. Okay. So you want break for 10 minutes, then you do the lab.
First, like one simple one we will do and we can take the break. in my opinion.
Yes, that's fine. Fair enough. Okay, first thing we'll do the
Okay.
this lab. Okay.
Okay.
Let's do that.
Okay.
So, this is my OSPF, right?
SPF.
I think this is. That's what I will do first. Take new. Let me copy the same, right?
Okay.
And then I will change this one.
SPF.
This is a 4 OSPF. Is it okay, right?
Yes.
Yes.
Let's open this. I think here it's running
Yeah.
EHRP, right?
Yes.
So IP
Mhm.
EHRP. Show IP route. Okay, so here EHRP is running. So how do I remove, guys?
No.
No
EHRP?
IP route.
No IP route.
Yeah.
Yeah.
That's it, right?
Yes.
So no router. EHRP 10, I think, right?
Yes. Yes, value was 10.
So IP route EHRP. So it has removed, right?
Yes.
Right. So let's check this one. Is showing expiry because no, that neighbor is down, right?
Mhm.
So it is showing expiry. And is down. So let's do this lab. I'll remove the EHRP, guys. No router EHRP 10. Show IP interface brief. So I'm running two network here, one network here. Okay. The first thing is what I'm going to configure. So first things I'm going to configure with this router.
Mhm.
Okay, show IP interface brief. Okay, so I'm running one network here. So configure router OSPF. If you give question mark, here it will fall
Process ID.
process ID, not your autonomous system number.
Yes.
Okay, so process ID I'll give 10.
Okay.
So it should be same. Remember this. Same thing. Network. So which network you have to advertise? 1.192.168.1.0.
Then
Right? If you give the question mark, it asking OSPF wildcard bits. We cannot give the subnet mask key. Guys, remember this. While configuring the OSPF, you should give your wildcard mask.
Wildcard mask.
Wildcard mask. What is the wildcard mask for this?
000
255. Correct.
Yes. Yes.
So if you give question mark, it will ask you to area. Even if you press
Area
enter,
ID.
incomplete. Okay, it asking area. So area I'll put area 0.
0.
Okay. Show IP route OSPF. Still no updates because other router we are not configured.
Configure.
So okay, so let's configure this guy now. OSPF 10 network 192.168.2.0, right?
Yes.
255.
0 1. Yeah.
This also put it in area 0. So remember, OSPF is a slow routing protocol, guys. So it takes time to update.
Okay.
Right. So there is another network which are not configured. That is a 10 network, right?
Yes.
Yes.
Okay. OSPF 10 network 10.0.0.0. So what is my mask here?
0.255.
0.255.
Then
255 to 55.
then area 0.
0.
That's it. And this side also we are
Yeah,
not
yeah.
confident, right?
Yes.
Yes.
So 150. Router OSP. Then network 10.0.0.0. 0.
255.
Show IP out OSPF.
Yeah.
Okay. So now it should form the adjacency. So it takes time because of the AD value, right? Administrative value. So
It's
it
110.
takes time.
Okay.
Now check what are the routing protocol you show IP interface brief. One dot zero network. Check this side. Okay, so now it's loading, right? Can you see? OSPF adjacencies. It takes time.
Okay.
Right. Now we can see show IP route OSPF. So I think it has learned, right? O stand for OSPF.
Okay.
Administrative 110 with the metric value 2 is going via 1.1.1 with the physical interface gigabyte 0/0/1. Okay, same thing if you check here. So this guy also will learn.
Okay.
Okay. So show IP route OSPF. This guy also learned. So now we can able to reach to other guy. So 192, 168. And this is my 2.1. 2.0 network is pinging. Okay, I can reach to 1 and 2. I can reach to 3 and 4. Same thing you can check from this side. This side. Related to 168. 1.4 helping directly to the PC. Yes, I have reachability, right?
But 80% it is reachability, right? Why not 100?
First packet will be
First
dropped.
packet.
Okay, if you ping, first packet will be
Yeah,
dropped
now it
because
is
of
getting.
R.
Yeah.
First
Yes,
packet
now
will
it
be
is.
dropped.
Yes.
Okay, so now if you ping once again,
Yeah.
it will not drop
Yeah.
your single package. That is
Exactly.
to for the ARP gas.
Yes.
Okay, so this is very simple lab what we did.
Yes.
Any questions here?
Like, how are we deciding? This is a area a 0 only.
You can decide.
Like,
Always
we are
remember,
not configuring it anywhere, right? This should be area 0 and another should be area 1 or something. So here we have directly taken network area 0, right?
area 0.
Yeah. Like, how do we decide? Like, if you have multiple routers, like, how do we decide this should be area 0 and other should be like area
So
1 or
how we
2?
can decide is you have to select one of the area that area routers belongs to your designated router. For
Okay.
that area, all the routers should connect it to area 0. It is
Okay.
nothing but your headquarters.
Okay.
All the branches office are connected to your headquarters
Okay.
network. Any updates you have to give only for your headquarters, not directly to the other offices.
Okay.
Branch office. You can
Fine.
select whichever you want. Whichever router you want, you can make them as your area 0, area 0.
Okay.
Okay. And it should be connected to all areas.
Okay.
Okay.
Okay. Good.
What about other guys? Any questions here?
Muhtaj.
Whatever Ishika, Soundarya, Imelda, Swati.
No, Taj, I don't have any doubts.
No, Taj, I don't have any doubts.
Swati. Swati is there. Okay, so we'll jump to the next lab by using your Piyush, are you there?
Yes, sir.
Let's jump to our next lab.
Mhm.
Okay, our next lab will be these guys.
Okay.
Okay, so let me change this to OSP.
OSP.
Okay, so guys, what we have to do, we have to remove the EHRP. We will do this. At the same time, we will take break now. Just remove the EHRP configuration. And also, I want you people to remove this color. So let's put it with the same one. I'll put it this all into. This is my area. Area as well.
0.
This is area 1. This is okay.
Area, if you're giving area 1 and 2, that should also have have other routers, right?
Yeah, they have router, right? This is my.
But the whole, all the 3 routers you have considered as like one, 0 area.
Only for the network, for 10 network, 20 network, and this network, I'll put it in area 0.
Okay.
And this network, okay, it's the router 1.0 network or area 1. Okay, and three
okay.
networks, 3 network belongs to your area 2.
Okay.
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 So this lab will do it. Okay. So we'll take one break.
Okay.
Okay. So after break, so we'll start doing this configuration, guys.
Okay.
Okay.